Steps 6 and 7. Step 6, discounting the cash flows, and step 7, the final step, the decision. And this is the fun stuff to me. This is, uh, it's not a lot of calculation. It's simply step 6 is just bringing numbers in from prior steps and putting them in a nice table, and then just doing simple discounting. Okay, and this is why it's called DCF, discounted cash flow analysis, because basically the next to final step, we're just going to simply discount the cash flows back to present value. And so step 6, discounting the cash flows, I suggest setting up a table years 1, 2, and 3. And let's first bring our after-tax cash flows from step 3. So if you go back to step 3, all we're doing here is taking the after-tax cash flows that we calculated for years 1, 2, and 3 and organizing them on our table. So after-tax cash flows from step 3, years 1, 2, and 3. The next step, or the next item, let's go grab our before-tax equity reversion from step 4. Okay, the $32,317, and let's put that in year 3 also. So year 3, we have lots going on. We got the after-tax equity, or we have the after-tax cash flow in year 3, but we also have the sale of the property in year 3. And $32,317 represents the before-tax equity reversion. If we take the capital gains tax that we paid from the end of step 5, okay, step 5 capital gains tax was $3,167, and we subtract that out from the before-tax equity reversion. That gives us what's called the after-tax equity reversion. So in year 3, we have two major things going on. We have the after-tax equity cash flow, and then we have the after-tax equity reversion. If you sum up all the cash flows, that gives us the total benefits for years 1, 2, and 3. And the problem now is that the benefits are spread out over 3 years, 1, 2, and 3. And the benefits are in different units. They're in year $1, year $2, and year $3. And what we want to do is compare what our investment is today to get into this deal with the present value of the estimated or anticipated benefits over the holding period. So what we need to do next is discount these benefits in years 1, 2, and 3 back to year 0, back to today, so we can do an apples to apples analysis. How much this investment cost us versus the present value of the total benefits. So we're going to do discounting, and our discount rate, remember, was given to us. The investor's required rate of return, their hurdle rate, their discount rate is 15%. So we're going to use a 15% discount rate. And again, you could do this in your calculator, but when you're doing an investment analysis for a client, they want to see the calculations. So that's why I'm doing this in a table. It might not be the quickest way, but if you're presenting this analysis in a report or doing it for an exam purposes, you want to show your work. You want to show your calculations. And this is a nice way to show the steps in the work. But let's calculate the present value factors at a 15% discount rate for 1 year. And again, you could use your calculator, but the formula is pretty simple. The formula for discounting is the amount, or in this case, we're going to calculate the present value factors. So it's the present value of $1 is in the numerator. And in the denominator, it's 1 plus I to the nth power. And I is the discount rate, or the required rate of return. So for year 1, it's 1 divided by 1 plus 0.15, or 1.15, to the first power. And that equals 0.869565. So what this is telling me, at a 15% discount rate, an investor, okay, this investor would be indifferent between 86 or 87 cents today and $1 1 year from now. That's how you can interpret that discount rate. And if you multiply the total benefits for year 1 times the discount rate for year 1, okay, this is multiplication, you get $1,156.91. So we've taken 1330, which is at the end of year 1, we've discounted it back 1 period, to $1,156.91. So year one is taken care of now. Year two, okay, we have the total benefits here. We need to discount it back 15% 2 periods. So the formula here is 1 divided by 1 plus 0.15 to the second power. And if you do the math, do the calculation, you get 0.756144. And that tells me this investor at a 15% discount rate for 2 periods is indifferent between 75 cents today or 76 cents today and $1 2 years from now. But if you multiply the 0.756 times the 1,727, that gives us a present value of $1,306.58. And then go on to year three. Okay, year three, the total benefit's $31,292 because we sold the property. The discount rate would be 1 divided by 1 plus 0.15 to the third power. That gives us a 0.657516 discount rate for $1. Multiply times $31,292, and that gives us the present value of $20,575. Now add up the present value of the total benefits for years 1, 2, and 3, and that should equal the $23,038.99. So that's the present value of the total benefits. And the benefits include the cash flow, the tax shelter, the appreciation and sale of the property. That's all incorporated and included in this one number, which is in today's dollars, $23,038.99. That's basically the number, the bottom line. And that's why we did steps 1, 2, 3, and 4, and 5, just to come up with this number. But it's all summarized and contained in today's dollars and that number. Then, once you have that number, step 7 is the decision, and step 7 is just simple cost-benefit analysis. Okay, you look at the present value of the total benefits, and you look at the cost of the investment to the investor. And it's just cost-benefit analysis. So the present value of the total benefits is $23,038.99 from above. The initial equity, okay, remember the investor had $55,000 to spend up to, okay, but we didn't invest that much in this property because the acquisition price was $135,000 and we only put in 20% of that. Remember, we borrowed 80%. So the lender put in 80%, we had to come up with 20% or $27,000. So here's our benefit, $23,038, and here's the total cost of the investment to the investor, the $27,000. Would you pay $27,000 for something of benefit of $23,000? No. Okay, the cost is higher than the benefit. So that's what we call a negative NPV investment. The net present value is $3,961.01, and that's a negative. All right, the sign is very important on the net present value because a negative means no. Okay, when the NPV is negative, we reject the investment. When it's technically it's zero and it's positive, we accept the investment. There's also a relationship between net present value and the internal rate of return. Remember, our required rate of return, our hurdle rate was 15%. And I can tell right now by the negative NPV, we did not achieve 15% return. In fact, I calculated the actual internal rate of return on this investment, and it's less than 15%. It's 8.8%. And this was done using Excel. But you can also do this on your calculator using your cash flow menu. So the internal rate of return is less than the required rate of return, and that's also a reject, right? We only accept investments when the internal rate of return is greater than or equal to the required rate of return. That would be an accept. So this is it, okay? This is, we did all this analysis, all these steps to come down to step 7 in our decision, our NPV and IRR decision rules. And that's the investment problem. So, you can practice this on additional investment problems, but here it is, steps 1 through 7. And once again, take it step by step. I know it's a lot of number crunching, and if you look at the problem as one big problem, you're probably going to get overwhelmed. But if you break it down into pieces and you do each piece, piece by piece, it's really not that complicated. It's not rocket science, but it is a little tedious in some of the calculations. The nice thing about spreadsheets, you can put a lot of these calculations on a spreadsheet, and it's much quicker, and it helps you out quite a bit. In fact, that's another nice exercise to get to know the investment problem, is to create your own investment spreadsheet. And once you do the cell formulas and everything, you kind of learn the process and the steps that way too. The other way to learn the investment problem is just keep doing different investment problems over and over again with a calculator and a pencil and several pieces of paper. But it's good stuff, it's basic stuff, but again, whether you're analyzing a 2-unit apartment complex like we did in this example, or a regional shopping center, it's the same basic concept of discounted cash flow analysis. Just the shopping center has many more leases, reimbursements, and some other bells and whistles that make it a lot more complex. But it's still fundamentally the same process. Just estimating future cash flows, discounting them to present value, and doing cost-benefit analysis. It's as simple as that. So good luck with it, and practice. Practice, practice. Bye now.